In this explainer, we're going to break down the core philosophy and the main paradigms of the Python programming language. We'll really focus on how its design makes it possible for developers to solve some pretty complex problems with, well, remarkable clarity. So let's start right at the beginning with the Python philosophy. It really all comes down to a fundamental question. Why was this language even created in the first place? What problem was it trying to solve? It all starts with this one core truth. And this is a great line from a script at the University of Regensburg. Computers are incredibly dumb. Now, that might sound like a joke, but it's not. It's actually the central challenge of programming. A computer only does exactly what it's told with absolutely no room for error or, interpretation. And this is precisely the problem that Python was built to solve. Its entire design philosophy is about making code as human-readable as possible. The idea is to free up developers so they can focus on the actual problem, not just the tricky syntax that the machine needs. So, how does Python actually pull this off? Well, this whole philosophy is brought to life through a few key concepts. You can think of them as the building blocks that support its elegant simplicity.
The feeling of using Python is just perfectly captured in this famous XKCD comic. You see a programmer who, after just one night, feels like they're literally flying. They're getting these powerful results with what feels like effortless commands. So how is that actually possible?
Well, this slide shows two of the key reasons behind that feeling. Over on the left, we have dynamic typing. This means Python's interpreter automatically figures out data types as the code is running, so you don't have to declare everything beforehand. And on the right, we've got whitespace significance. In Python, indentation isn't just for style points, it's part of the actual syntax, which forces the code to be clean and super readable. And underneath all of this is a really powerful unifying idea. In Python, everything is an object. A number, a piece of text, a function, even an entire library of code, they're all treated as the same kind of consistent, predictable thing. And this design choice is a real cornerstone of the language's power. This everything is an object idea leads us right into our next section, the power of modules. Python's huge ecosystem is built on this very principle of creating and sharing reusable blocks of code. Now, the entry point to this whole ecosystem is the import statement. So here, the script bar.py uses one simple line, import foo, to pull in all the functionality from another file. With just that one command, everything inside foo.py is now ready to use. And check this out. When bar.py is executed, look at the output. The text loaded foo actually shows up first. This is a really crucial insight. The import statement doesn't just make the code available, it actually runs the code in that module. It makes the whole concept of importing very real, very tangible. And just a quick but really critical convention. Import statements should always be placed at the very top of a file. This gives anyone reading your code an immediate, clear overview of all the external tools the script depends on. It's just good practice. So this brings us to the logical conclusion of the whole everything is an object philosophy, which is object-oriented programming, or OOP. This is where that core idea really gets to shine. Okay, first things first, we need to understand what a class is. The best way to think about a class is like a blueprint. Say the blueprint for a car. It defines all the potential properties and behaviors of a car, but it's not an actual car itself. It's just the plan. And from that blueprint, you create an object. An object is the actual thing you build from the class. So if the class is the blueprint for a car, an object is a specific red Tesla with a unique serial number that just rolled off the assembly line. It's the real deal. The behavior of that object, what it can do, is defined by its methods. A method is really just a function that belongs to a class. For our car object, methods might be things like start engine function, accelerate function, or turn left function. They are the actions the object can perform. And the internal data of an object is stored in its attributes. These are just variables that hold its specific state. So for our car object, attributes could be something like color equals red, current speed equals 0, or fuel level equals 95%. They describe the object's current condition. So this all comes together in a pretty logical 4-step workflow. First, you define the class. That's the blueprint. Second, you initialize it using a special method, a constructor, which sets up the object's initial attributes. Third, you add methods to define its behavior.
And finally, step 4, you instantiate it, which is just a fancy way of saying you create a concrete object from the class, so you can actually use it in your program. Okay, theory is great, but let's look at a practical example to see how all these ideas, simplicity, modules, and objects, come together to solve a really common problem. So here's our problem, a raw text file with comma-separated values. Now, it has structured data in it about superheroes, but in this state, it's not immediately useful for a program. It's just a wall of text. And here is the solution. Just notice how concise and clear this Python script is. It imports the built-in CSV module, and then it uses what's called a reader object to parse the entire file in just a few lines of incredibly readable code. And here's the payoff. We see the result of that approach, and the output is perfectly structured. It's easy to weed. All the messy, complex stuff about parsing the file, that was handled for us by the CSV module's object, leaving us with just a clean, usable result. Which brings us to the ultimate takeaway here. Python's design philosophy, its powerful libraries, and its object-oriented capabilities, they all serve one primary goal: to let the programmer focus on the big picture, the main problem, rather than getting lost in the weeds of low-level implementation details. And this all brings us to a final question for you. Now that you understand the philosophy and you've seen the tools in action, what complex problem will you solve next with Python?